Okay. So welcome back to another session of the Lunch and Learn. And if you have been with us before, you know that we're doing a series on an end-to-end machine learning challenge, where we're going to cover all the main phases of a machine learning development cycle. So let me do this. Let me see if I can change the slide. Okay. So in the Lunch and Learn, usually, the main goal of this initiative from the OMLDS is to share situations, share knowledge in the data field, machine learning, also AI, and we're going to talk a little bit about that. We do some introductions, okay? Since we are kind of pressing time because we want to finish at 1, the co-organizers are going to introduce yourselves. I want to introduce ourselves, but we have a Discord channel, and I posted the link for the invite. If you haven't been, in our Discord, please do, and please let us, introduce yourself. Let us know, where you come from. What background, etc. So we can, use the best of time. Then, in the machine learning, we did a little bit of adjustment, okay? Because we were going to finish this session. We were going to finish all the feature engineering. And Ron, which is one of the co-organizers, was going to prepare a mini presentation on how to manipulate geospatial numeric data and to extract, for example, distances and all that. We're going to postpone it for August, okay? And what we're going to do is finish some of the feature engineering that we were doing, creating new features from our raw data set, and try to get into the next level, which is feature selection, okay? Because sometimes when you have already your clean data set, sometimes in the category variables, when you expand it, doing like a one-hot encoding, what is called one-hot encoding and double encoding, you're going to get a lot of features, a lot of columns, and you have to then try to prune those features to get it to a manageable number. So we're going to talk a little bit about that in this session. So introductions. My name is Ricardo Serrano. Welcome you. I'm one of the co-organizers, jointly with Ron Bergeron and also Kevin Coe. My background: I have a bachelor's in industrial engineering. Also, I have a master's in engineering management, and I study law. Okay, I have a Juris Doctor degree, but I didn't practice. Okay, so I get the best of the both worlds. I kind of get the knowledge, but don't get the headaches. Anyway, my main job really is appraising. I appraise real estate, more personal property, aircrafts, marine equipment, okay, boats, etc. So, but not here in Florida. I do most of my work in Puerto Rico. And I've been involved since 2020 in the OMLDS because I was doing like a career change. It hasn't happened fully yet, but I'm still working on that. So I've been around 4 years, doing some data science and also working on a project that probably Ron will tell you. So Ron, give us your intro.
Sure. Thank you, Ricardo. As Ricardo said, I'm one of the co-organizers for OMLDS. I run a small consulting business called Adventurous Analytics and Data Science and Machine Learning. I got started in 2019 with doing that. I have a history prior to that, running like a small IT department as the director and then VP of data management and analytics. I also have an industrial engineering undergrad degree, and then I went on to get my MBA later. And I've been involved with OMLDS since 2019, the same time Ricardo and I got involved in a volunteer project that was being done with the local foster care system here in Orlando. And I think that's it.
All right. So let me ask, the audience, okay? Is this your first time that you get into one of the launch and learns of MLDOS? Please put a 1 in the chat, okay? So tell me more or less, how much of the audience, are first timers, okay? Okay, Lily, Larry, good, good. Okay, so we have 2 new members. One of the things that I wanted, what I asked Ron is that we are in the 4th session here of the end-to-end machine learning challenge, but you can watch previous sessions because we're recording every session. So you can watch in our YouTube channel, the MLDS YouTube channel. You can watch it there, and you have the link in the chat. Okay, so you can get up to speed. But I welcome you. So for the new members and also for the current members, if you are not yet in Discord, please I welcome you to join us there. Okay, that's where we gather online, a continued discussion, and try to sort out different things. For example, I see Remco. I remember that he had a question, in one of the sessions about the Seaborn package, and if we could extract some information from the linear regression model that we were visualizing. And I look into it, and the author of the package of Seaborn said that his main goal was in visualizing, not in getting that statistical parameters out there. So there's an answer in the Discord, Remco. So if you're hearing me, go to the Discord, and you have your answer there. And anyone that have an answer that I cannot, a question that I cannot answer right away, I'll bet you that I'll look into it and try to, in the Discord, try to at least try to answer it as fully as possible. Okay, so here the Discord channel. Remember the link. The link is in the chat. If you have any problems, please contact us through the meetup, and we'll get you. We'll get you a new link. Supposedly this link doesn't expire, but I don't know the other rules of Discord. So maybe they say that it doesn't expire, but things could happen. Okay. Anyway, so this is the end-to-end machine learning. Okay. We are dealing with the data set from Kaggle that we chose. And this data set is a simulated data set on credit transactions fraudulent detection. Okay. So you are going to see that one of the challenges in this data set is that the class that is going to tell you if the transaction is legit or not is highly imbalanced. Okay, so that's one of the things that eventually in the modeling we're going to have to deal with it. There's a GitHub a repository. We still haven't been updated yet, but I'll do my best during the following weeks to update it with the information to get it all the information that we are doing, get it up to date. And we're doing our main tool for developing these sessions is using Google Colab. Okay, because Google Colab, one of the good things that has is that it has all the major libraries already installed in their kernel, and you don't have to create a virtual environments to use Google Colab. So we're trying to make it easy, and also you can follow with the link that I'm going to provide to you, which is this link. Let me do that so we are in the same page. Let me see. Link here. Okay. Okay, this is the link for the Google Colab. Okay, so it's already posted in the chat. Okay. Okay, so remember that we're following a specific cycle in terms of what are the best practices to develop a machine learning, or in general a software tool. So we already have our business understanding. You know, we're fictitiously, we are saying that there is an institution that contracted us, a data scientist, to work on proactively detect transactions that could be fraudulent, okay, from the credit card, you know, universe, okay. Then we did some data understanding. We are doing some data preparation, doing some analysis on the data set, and also doing some feature engineering. In other words, creating new features that are going to help the model to give us a better prediction, a better chance of getting a good prediction. Also, we are going to deal with feature selection, and you'll see why it's important in this case to do some feature selection, because your data set eventually is going to grow. Okay, if you have a lot of categorical variables, just as, you know, for example, zip codes, cities and states, different categories, etc., your database, your data set is going to grow. So you need to do some feature selection, and we're going to be also talking about that. Then we're going to do our modeling, and we're going to use our scikit-learn library, which is the traditional library in Python to develop machine learning models. But also, we're going to use a tool that is called PyCaret. And PyCaret, what it does is that it automates a lot of steps that usually take code to develop, and it's based on scikit-learn too. So they talk the same language. The only thing that PyCaret, with a couple of commands of scripts, you can develop very easily a lot of modeling, and you can choose, you know, which models are the best for this you know, for this data set. Once we do that, then we don't stop there. We do the deployment. And in the deployment, we're going to use a tool called MLflow. I already, you know, been studying the MLflow, and let me tell you, it's a very good tool for versioning, okay, for capturing all your models, doing the version, and then it gives you also scripts to put it into production, okay? And we're probably going to use Streamlit, which is you know, a very light kind of a dashboarding tool for deployment. And if we have time, I found another tool for deployment, which comes from the company called Posit today, which is our studio. They develop something called Shiny. Okay, if you are in the Rverse, you know what Shiny is. So they developed Shiny, but for Python. And it's getting a lot of traction because I've seen a lot of webinars recently, you know, talking about the tool. So that's basically a nutshell, you know, where are we going? Now, before we start, you know, our dissecting of the data set, there's an elephant in the room, right? And you know what I'm going to talk about. I'm going to talk about OpenAI and ChatGPT. So I have a, you know, a informal polling here for you guys. And the first question is, put a 5, write a 5 if you are using regularly ChatGPT. It could be for data science, or it could be for anything else, okay? So if you can put a 5 in the chat, okay, you know, that you're using regularly, maybe once a day, maybe, you know, twice every 2 or 3 days, but you're using it regularly. Okay, good. Okay, every day, excellent. So Lily, and you can talk, you know, what are you primarily using it for?
I'm using like mostly for coding.
Okay.
For instance, if it's like in this case, unbalanced, I would just do probably like over set. Like I'm assuming probably fraud will be like 5%, and another 95% will be like the regular transactions. So I would just do oversampler. I would just do like and to like I know there is a libraries, but if I don't know how to do it, I would just like
right.
put like a query in ChatGPT. How do you like deal with unbalanced data, for instance, like, and it just gives you like codes and everything, and it's just very convenient because you can just like there is like a on the right section where you can just copy the code and you just can modify it. Like you don't have to just like type in like
right. All right, that's
that
good.
mostly
That's good.
but mostly for coding questions. Like
Okay, excellent, excellent. Thank you for your feedback. One, I can talk in my experience, but something similar to Lily, I've been using for probably troubleshooting, certain code that I cannot get running. But also one of the things that I was using it is for resume building. Okay. So for example, I have a chance, to participate in an interview, in a job application for an insurance company. They were looking for someone with data science experience in survival analysis, time to event. And one of the things that I found very insightful is that you can give ChatGPT the job application. You can say, okay, summarize, most of the main points of this job application that I have to look for and, talk about it. And it will give me a summary. Of course, ChatGPT, remember that it's a prediction tool. Every time you run it, you run the prompt, you're going to get different answers. Okay, so you have to establish certain rules of engagement in terms of how you're going to deal with those variances of that of those answers. And the same thing in coding. For example, if you get ChatGPT, I want you to write a code, okay, to describe this variable and then try to create these columns. So it's going to give you a first version. Maybe it doesn't work, you have to keep at it, but then eventually if you repeat that process, eventually you'll get the right answer. So for those that are not using regularly ChatGPT, or this is the first time that you are aware of it, I encourage you to get a little bit curious about ChatGPT and other tools out there, because definitely this is impacting our profession, okay, in terms of data analysis, data engineering, software development, web development, etc. Because you can use ChatGPT. You can have two paths here. Okay, you can say, well, ChatGPT is going to replace every program in the world. I don't have to care about that. Okay, I'll do some other thing, right? You can get that mindset, or and that's what I'm trying to the message I'm trying to transmit is that you can choose ChatGPT to get better at what you're doing. All right, use it as your ally. Okay, and you can have a lot of insight just working with the tool and trying to get more efficient or more proficient or upskilling your abilities in could be coding, could be analyzing, etc. Also, remember that ChatGPT is like any tool. It has its shortcomings, and you have to be very careful on how to use it. For example, I won't recommend dumping any proprietary data or private data into ChatGPT, even though OpenAI, the creator of ChatGPT, says that they don't record or do anything. You don't know. Okay, so be careful about that, because there could be some seeping information that probably organizations want to keep private. So be careful, but study it. Try to get the best of it. Play with it. Okay. So that's my message for ChatGPT. And in fact, probably we'll be using some of that artificial intelligence generative artificial intelligence when you will deploy the model. Okay, because I've seen some use cases that really, gets the deployment faster than if you do it, by your own. Okay. All right. So that's about ChatGPT. Let me see where I am. Okay. So we're still working with our data set, the fraud detection data set. And I'm just going to give you a quick, no, this is the second one. Sorry. This is, okay, here we are. Let me see where I'm at. Okay, so this is the notebook that I posted in the chat, in the link. This is the main notebook that we have been working on. So we already did. I'm going to do just like a preview of what we have done. We already did the reading of the raw data. Okay, we know more about how many columns do we have originally. There are 22. We don't have any duplicates. We verified the duplicates rows, right? We verified the missing values, no missing values, thank God. We did some descriptive statistics, okay, with the command descript. Also, we did some histograms to see more or less the shape of some of the, some of the features, especially, for example, amount of the transaction, which could be an interesting feature to try to investigate. Very highly skewed, so probably would need some transformation there, right? We also confirm that our data set is highly imbalanced. In other words, for every 100 every 100 transaction, less than one is fraudulent. Okay, so we have a very small flag transactions that are fraudulent. So that's going to be something to think about. I don't know if we've covered this, but one of the things that we all also want to do is investigate what are the categorical variables that we have. And we can do this with this command, which is called select the types in Python. And when you do include object, you separate from all the data, so you separate only the variables or the columns that are classified as objects. And usually the categorical variables are objects. They could be string, or they could be text, or they could be labeled data. Labeled data is the categorical one. And if you do this, and unique, what you're going to do is a list of each of those potential categorical variables and how many unique values you have. For example, in the CC number, which is the credit card number, you have 983 unique values. So from a data set of around 1,200,000 plus transactions, that's very interesting because you have only a subset that it pertains to a particular credit card number. Okay. Merchants, the name of the merchants, you have 693 unique labels. Category, you have 14, and so forth. So if you try to plot this, okay, each of these categories, if you have to plot this using regular matplotlib, the problem that you're going to have is that one of the categories, for example, transaction number, that has this unique values, 1 million, more than unique values, is going to mess with your scale. Okay, so you're going to have a big chunk of the scale getting the most attention to that column, and then all the columns are going to be very, very tiny. So that doesn't work, right? So what we're going to do is we're going to filter those columns of categorical variables that have less than 15 unique values. Okay, so we can then have a better idea of categories, how many labels are, the count of them, and also try to see if we can reduce that that list of potential columns. And if you do that with this, with this function, it's basically a subset function, right? draw.log, all the rows, and then the columns are going to filter by the unique values that are less than 16. Okay, 15 or 15 or less. We're going to transfer to, we're going to convert it to a column and to a list, and then you have your variable that contains a list of the categorical variables that have less than 15 unique labels. You have category, you have gender, and you have, of course, the target. So when you plot that, we see the counts, okay, of different categories of transactions. And these categories pertain to, for example, if you use a credit card for food, okay, so where you go to buy food? Well, usually the supermarket, right? So that's groceries. But do you do it physically going to the grocery supermarket, or you do it online? So right now the category is going to be split, right? You're going to do your grocery, in a store, or are going to do your grocery shopping online. And there's a possibility, okay, this is, looking ahead, there's a possibility that you can test if the transaction is online, if it's an indicator that the transaction has a greater probability of being fraudulent than if the transaction was not online. Okay, so you can do that kind of test to see, if you get from these categories, you get a variable that can indicate if the transaction is online or not, then if it's fraudulent or not, if it'll help. All right. Then we have the gender. We have in this database, we have more females than males. Okay, so that could be interesting. What is the relationship between gender and fraudulent transactions? By being female, you are more exposed for your transaction to be fraudulent than male, or vice versa. All right, and then we have our fraud category. As I tell you, now you can see visually that is highly imbalanced. Okay. Any comments? Please, just go ahead. Okay. All right. So, because our data set is kind of biggish, right? It has 1,200,000 plus transactions. What we did was sampling, and the purpose of the sampling was to run it with a automated exploratory data analysis tool that is called pandas profiling. Because pandas profiling, some of the calculations that it's going to do, the more observations you have, the more time and more resources is going to go. So we did a sampling of 30% of this data set, and that's what we're working on this sample. All right, and we're keeping, we're doing a stratified sampling. We're keeping the ratio between the fraudulent transactions and legit transactions. Okay, so we have like a carbon copy, okay, reduce a carbon copy of our full data set. Okay. Then we start exploring certain things. There is a variable here called Unix time. And I talk about this. Unix time is a variable that takes the starting date of, supposedly when Unix was created, it was January 1st, 1970. And it takes from, whatever date, you want to reflect, it's going to take the total of the seconds from that date, January 1st, 1970, to the date that is going to be represented. And one of the things that you have to, try to see if that Unix time gives you more information or some information different from the transaction time. Okay, because you have that already. You have transaction day and transaction time. So the Unix time is going to give you a date, and that date you can then compare it with the transaction date. Okay, to see if they're equal, then you don't need Unix time. But if they're not, then you have to see if Unix time is a good predictor for the target. All right. So that's what we did here. Okay, we compare it using the standard deviation to see how far are they apart from, the transaction time, the transaction date, and the Unix date, or if the standard deviation is very small, that means that there's basically no difference between them. So in this case, when we compare it, we get a difference in the standard deviation of 0.001. In other words, almost zero. So we can say that Unix time has the same information as the transaction date. So that's a duplication. Probably we don't need Unix time. So right now we're trying to filter, different columns to see if they are they're useful or not. Then we did a correlation analysis. We did the Pearson, we did the Spearman, we did the Kendall. The Pearson is the numerical correlation, and Spearman and Kendall are more ranking, by the rank, by the order of the different variables. And one of the insights that we got from the correlation is that the latitude and longitude, that's the geo coordinates for when the transaction was created. Okay, so you have a special component within this data set that tells you the location when that transaction occurred. And what happens is, in this data set, the latitude and the merchant latitude, the merge latitude, are the same. Okay, they have a correlation of 0.9 or 0.99 or almost or 1. So they have the same information. So you can say also that, similar to the Unix time, the lat and merge lat, you only need one, okay, one variable. You can discard anyone, the merge lat or the lat, and the longitude and the merge longitude. So you only need 2 variables there. You don't need 4 for them. Okay, so also you can discard. You have, keep in your mind that, okay, these variables, eventually I'm going to get rid of them because they don't provide any additional value, information of the ones contained already in the data set. Okay, so far so good. If you want, give me a 1 if everything is okay. Just to make sure that you are there.
I have a question, actually.
Okay, go ahead, Ranka.
So aren't these results extremely biased by the ratio of the correct transactions and the fraudulent ones? So basically you're seeing the correlation being 1 because the majority is not fraudulent, but you should actually look at the correlation for the fraudulent ones, is my suspicion. But so what's
the thing is that here we're taking each variable as it is, right? So the Highland balance is in the target, okay? But if you compare latitude and merge latitude with all the transactions, you are not, you're not incorporating that information of if the transaction is fraudulent or not. You're taking all the transactions, okay? So you're doing like a pairwise comparison of each of these features in the data set and compare numerically and getting a correlation, coefficient, okay? But eventually you're going to see that there could be some, let's say, some distortion when you are doing, for example, feature selection. When you're doing feature selection, you are comparing the variables to the target. So there, you have to then make sure that your algorithm for the feature selection, kind of try to balance a little bit more the imbalance that is currently there in the is fraud. But for the correlation, only the is fraud is the one that is imbalanced. The other ones, they have the regular, the regular information. Okay, that's your question.
Not really. But,
okay.
So, but
yeah, for example, if lat, you can see that lat and merge lat has 0.99. Okay, so every numeric value that merge lat has basically corresponds with LAT. Okay, no matter if the transaction is fraudulent or not. Okay, because I'm not incorporating that into that mix. In fact, the formula won't allow it. Okay, so you have basically, if you do like a ranking of those features, you'll see that basically they are the same feature. Okay, they're just duplicating a feature. Okay, so the correlation, it really gives you the insight that, hey, this variable compared to this other variable, they are the same, they have the same information because they are very highly correlated. Okay.
Yeah, I think if it's exactly one, you're correct. But I just wonder if it's not exactly one, but say 0.9 or so. I wonder if the 0.1 difference is not caused by the fraudulent ones, for example. So then actually that contains exactly all the information you need to make it not one. So I was thinking mostly about the Unix time where you showed it. I was like, well, if it's fraudulent or it's not exactly, the difference is not exactly 0. I thought maybe there's 0.5% of fraudulent transactions, exactly the ones that cause it to slightly be off from 0. So and that's still...
yeah, that could be an interesting, but the correlation is not the tool, to gather that information. You have to separate the feature by fraud, right? The fraudulent transaction, and see if the correlation in one group differs from the correlation in another group, right?
Yeah, I think you're right there. Yeah.
Okay, and then you can you can test that. I don't know. I'm kind of skeptical, but it's something that it could be done. Okay, comparing both groups and see what is the correlation in this group versus the other group. Okay. All right. Good. I like those questions, Anyway. Okay, so right now, one thing that we did, and we are already, stepping into feature engineering, is to calculate the age of the customer. Okay. And there you can have some insight right away. For example, imagine that a customer has an age of 5. Let's say, that there was an age of 5. So that's very suspicious, right? Usually 5-year-olds, are not making online purchases or going to the store and making a purchase with a credit card. So that could be something that could be insightful. But to our, back to reality, let's put it that way. When we calculate the age based on the date of birth, because the data set gives you the date of birth, and then you can extract it from the minimum date of the transaction. You can extract it from other ways, okay? But I chose that because that at least gives me, the age when that person started using the credit card, right? So, but you can use the median, you can use the max too if you want. Okay, usually because this data set is not that the ranges are very discrete. Okay, there's only one year of data. They shouldn't change that much. Okay, so because the way that then when we calculate the age, we did a describe, right? To see which is the minimum, which is the maximum, etc. So the minimum is 13. And a 13-year-old in today's day, yeah, it's possible that he could be using a credit card. It could be investigated, but yeah, it could be using a credit card. For example, there's no 5, there's no 6. The minimum is 13. Then you have a max of 94. And of course, 94, 95, 100 years old, these are, persons that maybe, they having, circumstances that they shouldn't be using a credit card, and they could be also prone, to the scams, that we know it exists in the world. So it's interesting to see if we bin those ages to see what is the effect on his fraud. For example, if it's too young or if it's too old, do they have more propensity, to get fraudulent transactions than the one in the middle? The great majority. That's something that also we could be looking for. Okay, so we have the age, we did a scatter plot. Okay, you'll see the relationship between age and amount, and we concluded that basically there's no relationship. Okay, and you see that red line, that's a linear regression. Okay, from the age and the amount. And if you do a correlation, you will see that the correlation is very low. Okay, so we see that they are not appear to be highly correlated. So probably age and amount really, between themselves, they don't have, they're not significant between themselves. We don't know about the fraud. So let's explore that a little bit. So when we do now a categorical to continuous, visualization, and we segregate the ages by legit transactions and fraudulent transactions, now we see a difference. Okay, so in the fraudulent transactions, we see that the age, the median age, is lower than the ones that contain the fraudulent transactions. Okay, which is this one. So the question is, okay, is that difference, kind of statistically significant or not? And usually what we do is a t-test, right? A t-test, and then we check if the value of p is less than 0.05, then it points that those differences can be significant. In other words, they are from different distributions. Okay, so when we do a t-test, and this is the package is called Penguin, but it's not pronounced that way. Okay, it's pronounced Penguin. So when we do use that package, it's kind of a wrapper of SciPy, to give us a legible statistic. When we do that with age and with fraud, we get a p-value of 0. Okay. Also remember, usually these tests are geared for small data set. The data set that we have is around almost 400,000 transactions. So that can bias a little bit our test, but still we can do some corrections, right? Benforoni, etc., some corrections, and still we get a p-value at least of 0.05. So that means that according to that test, the age is significant. In other words, the age, the grouping of person with different ages between fraudulent and legit transactions is significant. So that could be a good predictor, right? Okay. So let's do something also about the amount. Remember that we checked the amount with the age and the amount, that there was basically no relationship. Well, the problem with the amount is that it's highly skewed, right? We have small transactions basically, to the left of our distributions, and then we have the rest of them, a very, right skewed distribution. So what we can do is transform that amount and get a log on that amount to try to, get a little bit less skewed, more Gaussian. So when we do that, we transform that feature, the amount, and use the log amount. Then we have this, and clearly we can see we don't need a statistical test, right? For this one, we see that the transactions of the legit transactions are much lower in the log scale than the fraudulent transaction. In other words, the higher the transaction is, the amount of transactions, the more probability is that there's going to be a fraudulent transaction. Okay, but yeah, we do also the t-test, and we see that also the p-value is 0. It approximates 0. Okay, so also amount, at least the log amount, can also be a good significant a good predictor of its fraud. So now we're seeing that there are potentially certain columns, certain variables that can be good predictors for the fraud rate. Okay. Let me see. We have 10 minutes. So the other one that I wanted to show you is category and fraud. And remember, category and fraud, category is a categorical, fraud also is a categorical. So we need to do kind of a stack bar chart to get a notion of how the different groups behave. For example, in this one, we can see this orange, chunk of the chart. That orange chunk is food and dining, and you can see, for example, that there's a big percentage of transactions in percent, right, of food and dining from legit to fraudulent. Okay. Excuse me, that was not the food dining. It's just the colors is a little bit, hard to distinguish. It's shopping net. Okay, that corresponds to shopping net. So shopping net, remember, we were trying to see if you do a transaction online, right, versus a transaction physically in the store, if there is a great probability that that online transaction has a great probability of being fraudulent than the physical one. And here is kind of, it gives you a hint that that could be happening. So in the shopping, the fraudulent transactions have a bigger chunk of the pie than the legit. Okay, and you can see the size of the orange. And you can see other ones, that have a bigger chunk in the fraudulent than in the legit size. Okay. So for this, we're going to do a chi-square test, right? A chi-square test of independence, because we're dealing with two categoricals. In other words, there's no numbers here. They're just labels. So if you research your chi-square test for, two categoricals variable, what we're testing is if the expected, right, the expected observations fall within, the range of the observed ones. Okay, so we have, from the configuration of those, of those quantities for each of the labels, we have an expected range, expected count of observations. If it falls outside that range, then that means that one of them is different from the other. Okay, that, in other words, they are not independent, right? And we're going to use our famous p-value, right? And you see that a lot of the tests that we're doing, the Pearson, the log likelihood, etc., it gives you different tests. All of them points to the thing that there is, that, in other words, they're not independent. They are, there's a significant relationship between category and fraud. Okay. Any questions so far? Okay, so we only have 7 minutes. So let me introduce you to the feature selection. Okay, yeah, the feature selection. And we created, with this, with this approach, we created age, we created log amount. I also created bin. I bin the age, I bin the amounts, etc. I also created a shop net, a shop net variable that says, okay, if the category ends with net, it's going to be 1. If not, it's going to be 0. So I can split that category into, online shopping and physical shopping. So when we do all that, then we have a data set that has 37 columns. Okay, and remember that originally we had 22. Now we have 37. And all the Unix, those variables that we said that could be discarded, the Unix time, the merc lat, the merc long, etc., are there too. So in the feature selection, and we're going to do for the, for the next session, in the feature selection, we have basically 3 groups of methods, to try to wean out, to prune our data set. In other words, to get the best features possible for our model. The first one is the filter methods. And the filter methods, what it does is that from the univariate statistics, for example, if the correlation is too high between 2 predictors, we're going to choose only one. Okay, so we discard the second feature, right? There's other ones, information gain, different ones that get that universe statistics. They don't do any cross-validation. They just do some statistical, analysis, and then discard some that are, redundant, duplicate, or superfluous. The good thing about the filter method is that it's fast. Okay, so even if you have a big data set, the run is going to be fast because there's not that much computation. Okay, in quotes, because I had a big problem running this in Google Colab, and Google Colab said that the memory that I was allocated, it wasn't sufficient to run the when in fact to run the correlation filter. So I had to notch it down a little bit. Then we have the wrapper methods, and the wrapper methods are based on a machine learning algorithm that we're going to use. We're going to use also cross-validation and try to exhaust all the possible combinations of features. As you can see, the wrapper methods is going to take more time because of the cross-validation and also because the space that we're using for determining, how many combinations can be, think about permutations, combinations of it, and then try to, get to a defined set of features that are highly predictive. Okay, and for that, we're going to use a package in Python called Boruta Shap. Okay, and it's based on a random forest. Okay, then the embedded methods, even though it sounds complicated, but the embedded methods, it already. For example, if you know regularized regression, lasso regression, for example, L1, lasso regression can be a tool to discard redundant or highly correlated variables. Why? Because lasso regularized regression, what it does is that any coefficient that is highly inflated, okay, in the formula, is going to get down to 0. And when you have a 0 coefficient, you basically are discarding that feature. Okay, and also it takes some time, in particular in this data set, because of the volume of the transactions. So what we're going to do in the next one, I believe that the next one we're going to be doing it in August. All right, I don't remember the date, but it's going to be after the presentation that we have scheduled. We have a presentation on data quality operations on August, I think August 19th, Saturday. After that Saturday, that a week, we're going to continue with some feature selection, okay, and then continue try to wrap up the feature engineering with the distance calculations from the latitude and longitude of the transaction and the city and the state that the person said his address is located. Okay, and the thing is that we want to test if the farther you are from your physical address, the more probable your transaction can be fraudulent. Okay, makes sense, right? Okay, all right. And anything else there, Ron?
Nope, I just unmuted myself and came back online here on the video. As you mentioned, we have a guest speaker on August 19th. Again, it's another online presentation, and that's a Saturday. It's going to be at noon Eastern time, and this is about data quality ops. And there's a guest speaker that has developed an open source tool called DQO or DQ Ops, and he's going to give a presentation about that and talk about data quality, which, as we know, as data scientists, is always a concern. A lot of what we do up front on some of these projects, we kind of infamously or affectionately refer to as data janitor work to clean up the data that comes into our analysis.
Yeah, that's what we are, data janitors, basically. All right. So I think that's a wrap. We're going to be, at least I'm going to be working on the repository, to get all this information there, so you can, review it and maybe, do some exploration on your own from what we have been discussing. Okay. So.
And this video will be posted online in the YouTube channel also within probably the next day or two.
All right. So I think that's it. That's all we have, folks.
Okay, thanks everybody for joining us today.
Yeah, and keeping up, with the with the pace there. Okay, excellent.
Okay, take care.
Bye.